Myself, Dr. Preeti Jagwani. I am Associate Professor, Department of Computer Science, Hyderabad College, University of Delhi. We are going to begin with a new topic titled as multi-threading in this series of our lectures, which is named as Programming in Java. The title here which we are going to explore today is about multi-threading. Now, this particular title is having its roots in one of the we can say the most basic topics of computer fundamentals, or specifically we can say computer operating system, and the topic from which this multi-threading is carrying its roots is multitasking. So, when we say multitasking, it is the process of executing multiple tasks simultaneously, and our CPUs or our modern machines are actually we can say well trained for this particular thing. Now, why do we need this? So, the idea is very simple, that we need to utilize the CPU up to its maximum efficiency, we can say. Now, when we talk about multitasking, this multitasking can be achieved in two ways. So, two ways we can say, either it is a process based multitasking, which is multiprocessing, and that is the kind of fundamental topic of multitasking. Another way in which the multitasking can be achieved is thread based multitasking, which is known as multi-threading, and that is what is our today's topic. So, when we try to understand this concept of multi-threading, we will till this point we are aware that this multi-threading is a specialized form of multitasking. Now, this is actually a feature that is allowing a Java program for concurrent or for simultaneous execution of two or more parts of a program. I would like to reiterate it here, that this is a feature which is allowing Java for the concurrent or the simultaneous execution of two or more parts of a program. So, that means a program can be divided into we can say what we can say into different parts. These parts are technically known as threads, and simultaneous execution of these threads is the concept of multi-threading. And the idea or the bottom line behind this multi-threading is similar as that of the multitasking, that is nothing but the maximum utilization of CPU. Now, here as I am talking about that a part that a program is going to be divided into various parts, each parts of a program, each such part of a program is called a thread, and here each thread is going to define a separate path of execution. So, the thread 1 will have a separate path of execution, and so is thread 2 is having a separate path of execution. Basically, we can say in terms of operating system, if we want to understand this concept of multi-threading, these threads are nothing but lightweight processes that are working within a macro process. So, we can say some micro processes working within the a macro process, some lightweight processes working within a full-fledged process. Now, when I am saying lightweight process and a full-fledged process, so what is the difference between these two? I will be covering this in a short while. Now, these programs which are kind of we can say exploring the facility of multi-threading, the idea behind writing these programs is to achieve the efficiency that in order to make the maximum use of the processing power available in the system, and that was the actually we can say bottom line, the agenda or the goal behind when we started with multitasking. So, multitasking is also there in order to make the maximum use of the available processing power. Similarly, the multi-threading is doing the same thing. Now, when we talk about multiprocessing, so each that macro process which I was talking about, that macro process or a full-fledged process is having a separate address in memory. So, process 1 is having its own kind of a space allocation in the memories, and so is process 2, and so on and so forth. And each process is given a separate memory area, and these are heavyweight processes. Heavyweight process in the sense they are having all the requirements. So, for example, they have their own registers and they have their own facilities. When there is a concept which is involved here, that is the inter-process communication, we name it as IPC in short. So, the cost of communication between the processes, the full-fledged processes I am talking about, is going to be very high in terms of resources, because it requires a complete context switch. When I am talking about complete context switch, this is actually switching from one process to another, and it requires saving the state of one process, loading the registers accordingly, then looking into memory maps, updating the various lists and program counters and so on and so forth. So, we can say yes, in terms of resources or in terms of expenses, we can say that switching from one process to another is actually a costly process. So, cost of communication between the two processes, when these are full-fledged processes, are actually very high, because when we talk about these processes, these are nothing but 2 or more programs which are running concurrently inside the system. Now, taking an example of this particular scenario, we can say we are running the Java compiler in order to compile a particular file in Java, and another at the simultaneous time we are also using a text editor, or maybe visiting a website or something of that sort. So, entirely different tasks. So, 2 entirely different tasks we are achieving at the same time. That means these 2 are different processes, and this is what your multitasking is. And here the smallest unit of code which is working is nothing but the program. So, that means a scheduler is going to dispatch program number 1, program number 2, or program A or program 2. So, a program here is going to be the smallest unit of code that is going to be dispatched by the scheduler. So, this was kind of, we can say, an overall overview of your process based multitasking, which is multiprocessing. Now, how this multiprocessing, which is kind of a very well known concept in fundamentals or in operating system, is going to be different from our today's topic, which is the thread based multitasking, which is multi-threading. Now, as I have told you that processes have different address spaces. Here threads are going to share the same address spaces. That means threads which are belonging to a particular process or which are belonging to a particular program will be kind of, we can say, covered, or will be explored in one of the in a common address space which belongs to that particular program or that to that particular process. It is not like that each thread is having its kind of a different address space. No, threads share the same address space, and thread is actually kind of lightweight, and so the cost of communication between the threads is going to be low, while the cost of communication between the processes was actually kind of too high, or that is an expensive process. Where in multiprocessing or in multitasking, when we say that a program is the smallest unit of dispatchable code, here the smallest unit of dispatchable code is nothing but the thread. And here when we say in our previous example of multitasking, we say that your system can perform 2 or more tasks simultaneously. Here we are not talking about the whole program, here we are talking about a single there we were talking about a whole system, maybe multiple programs. Here we are talking about a single program that is going to perform 2 or more tasks simultaneously. So, for example, let us take example of a text editor. So, text editor here is a single program, and on the one side it is a text editor can format the text, and at the same time it is printing. So, I have given a printing command, that printing is going on, and within the same text editor I am formatting a particular piece of text. So, as long as these two actions are being performed by two separate threads, which we are kind of yes, we can make it, we can ensure this. So, this text editor example of formatting text, and within that text editor giving a printing command or printing something else through that text editor is actually one program performing 2 or more tasks simultaneously, and this is what an example of your multi-threading. So, here 2 separate threads, one for formatting of text and another one for printing of text, are working within the same address space of that text editor, because these two threads or these two tasks are actually the parts of that particular single program text editor. So, we can say our process based multitasking that deals with a macro level thing or that deals with a big picture, while the thread based multitasking is going to handle the minor level or very minute or very micro level details when we talk about. Now, multitasking of threads requires less overhead than multitasking of processes, because of the very obvious reasons, as I have told you, that these processes are nothing but heavyweight tasks. They have their own separate address spaces. Inter-process communication is obviously a very kind of an expensive affair, and that is why it is very limited. And because of these two separate, because of each and every process having its own separate address space, context switching from one process to another will become kind of a costly task. So, that is why it is kind of, we can say, one must try and avoid this, because try and avoid this context switching, because in terms of resources that is a costly process. While when we talk about threads, these threads are actually lightweight processes, we can say. They share the same address space, and I have also given the example that how these addresses are going, how these threads are going to share the same address space, and they are, we can say, they work cooperatively. Now, how they work cooperatively, that I will be sharing with the help of some that I will be teaching with the help of some programs. Then there can be multiple threads within the same process or within the same heavyweight process. So, we will be kind of, we can look this scenario as of we have a heavyweight process, and within that heavyweight process we have some micro level or lightweight processes, we can say. And because of these lightweight processes are sharing one similar address space, the inter-thread communication is very we can say cheap, or simply it is inexpensive, because the address space is same. And so is context switching from one thread to another is actually lower in cost, while in the other one it was costly process. Now, another difference between this multitasking, between these two multitasking environments, that is process based and thread based, Java based programs make use of these thread based multitasking environments, while this process based multitasking is not under Java's control. So, who is controlling this thread based multitasking, and who is controlling this process based multitasking is also one of the kind of key points of the differences here. The Java programs are going to make use of thread based multitasking environments, while the process based multitasking are not under Java's controls. They are kind of, they are a task, or they are a management thing which is going to be controlled by, obviously, by operating system. Multi-threaded multitasking is definitely under Java's control. And if there one more line of difference between these two is, if there occurs exception in any one of the thread, it is not going to affect other threads, and that is what we can say is the advantage, or that is what we can say is the beauty, because despite of sharing the same address space, exception in one thread are not going to affect the other threads. And now here with the help of this figure we can visualize, or we can see that how these what is the difference, or what is the scenario of these two models of multitasking. So here the three we have a bigger circle. That bigger circle is actually representing the whole system. Now within this system we have three different circles in three different colors. So these three different circles are kind of representing processes. So we have process 1, we have process 2, and we have process 3. Now these processes are having their separate address space, and these separate address space is actually shown with the help of different colors. While if you can see in these small circles, that means within the process 1 or maybe within the process 2, we have smaller circles which are connected to each other. Now these smaller circles are representing threads here. So in this figure we can say this process 1, if you can see, are having is working or is getting executed with the help of 3 threads, T1, T2 and T3. That is what the process 1 is depicting. When we talk about process 2, the 2 separate threads T1 and T2 are there, and in process 3 only one particular thread, which is T1, is kind of getting executed. So what this figure is representing? This figure is representing what I have explained, what difference I have explained here. Within a memory space, processes are having their own separate address spaces, while within the processes, threads are working within the similar or within the same process, we can say. And here we have the threads which are working within a process and are so if you can notice the connection between the threads within this particular figure. So in this this green within this green circle, green colored process, if you can see, this T1, T2 and T3 are having connections between them. So these connections between them essentially depicts that they are belonging to the same particular address space. They are ready to cooperate with each other. Now how they are cooperating with each other, that I have told you that I will be covering in the later parts, but these are connected to each other, they are cooperative to each other, sharing the same address space, while the processes which are different are actually having different address spaces, and there is no connection between the macro level processes. So this is what this figure actually makes the things very very clear, we can say. So there are actually two ways to create the thread. One is extension of thread class and another one is implementation of runnable interfaces. And yes, because of through the programming we will be covering these two in a quite greater level of details. Now when we talk about this multi-threading feature, this multi-threading feature works in both types of system. Now what or which both type of systems I am talking about? So some students may have a confusion here that it is about the single core system and it is about the multi-core system. So let me kind of clarify here that multi-threading is a feature which works in both type of systems. So it is not like that the single core systems cannot be a system based on multi-thread. So in a single core system also multi-threading can be kind of we can say implemented or can be explored, because a single core system can be concurrently executing the threads, share the CPU with the thread, and each of the threads will be receiving a slice of the CPU time. So even if there is a single core system, there can be multiple threads which are going on, which are getting executed concurrently, and these threads are sharing the CPU with each thread receiving a slice of a specific slice of CPU time. So even in a single core system, two or more threads they do not actually run at the same time. This is something which we need to kind of understand very clearly, but the ideal CPU time is utilized. That means CPU is idle at one particular time, at one particular moment of time. One thread can take over and use that CPU time, and at another point of time when again CPU is idle, another thread can take over. So, even in a single core system, 2 or more threads do not actually run at the simultaneous time, but idle CPU time is utilized, and this is the way through which the multi-threading feature is working in the single core system. While imagining the multi-threading system in a multi-core system is actually kind of very obvious, we can say, because it is possible for 2 or more threads to actually execute simultaneously. In the single core system, multi-threads are being executed, multiple threads are being executed, but not simultaneously. In a multi-core system, it is possible for multiple threads to actually execute simultaneously. And in many cases, why are we doing this? The bottom line, as I have told you in the inception of this lecture, that it is going to further improve the program efficiency, and in many cases using multi-threading inside the multi-core system will further improve the efficiency of the program and increase the speed of the certain operations. So, here till this point, what we have learnt is that we have started our topic of a new topic of multi-threading, and it is having its own kind of roots within the idea of multitasking. What actually multitasking is, that we have seen, and how this is connected to multi-threading, that we have also seen, and then we have clearly dived into the difference of multi-threading and the multi-processing, the two modules of or the two ways of implementation of multitasking thing. And then we have seen what is the difference between the process which is actually a heavyweight thing, and what is on the other side we have tried to cover our thread, which is actually a lightweight process. So, we have kind of, we can say, understood the bottom line or the fundamental concepts of multi-threading. Now, going deeper into this topic, what we need to cover next is about the life cycle of a thread, or in other terms we can say what are the states of threads. So, a particular thread will always exist in any one of the following states. What are these states? These states are new, active, it could be blocked or waiting, then it could be timed waiting or terminated. So, these 5 are the states of the thread in which a thread can a thread will definitely exist in any one of the following states, either it is in the new or maybe active or blocked or time waiting or terminated. Any of the 5 states a thread will have to be in. So, this is what we have covered in this lecture, and yes, more details of this life cycle of threads I will be covering in the next lecture. Here is a list of references which is being used for the preparation of lecture, and hope you have enjoyed one. I will see you in the next lecture. Till then, take care, goodbye.